Hi guys, welcome back to another science lesson. Today we're continuing on with our properties of matter unit, and we're going to look at some of the states of matter. Now before we do, let's take a little quick review at chemical or physical. Here's something that we see, and it's hard to decide sometimes. Is this a chemical or physical change that happens? Well, scientists sometimes have to do experimentation. You can try it at home too if you have these ingredients. Let's take a look at chemical or physical.
Mentos plus soda produces an impressive fountain of bubbles. But why? Let's say you ask your friends and you search online, but you come up with conflicting answers. Some sources say that sugar reacts with a diet soda to make the fountain. It's a chemical reaction. Other sources say it's a physical reaction caused by the rough texture of the candy.
What do you mean, rough texture? Mentos are smooth and round. It can't be sugar. Soda already has sugar in it. That's why you have to use diet soda.
How are you going to decide who is right? You could choose based on which person you like better, or which website is more entertaining and appealing. But these are not good methods for getting to the facts. There is a reason Mentos react with soda to produce a fountain of bubbles, and with the help of the scientific method, we can figure out which explanation is correct. Let's begin by testing the first explanation we heard, that the reaction is caused by a chemical reaction of sugar and diet soda. If the sugar in our Mentos is the cause of our eruption, then we would expect other sweet candy to produce a similar effect. So let's test jelly beans, gummy bears, and sour watermelon candies. The other candy produced much smaller reactions than the Mentos. The results did not support our hypothesis. Now let's test the second explanation, the idea that the reaction is caused by the rough texture of the Mentos. If a rough texture is all that is needed to produce bubbles, then sand should also produce a reaction. And it does. In fact, when we did this experiment, sand produced a higher fountain and got more of the soda out of the bottle than the Mentos. The results support our hypothesis. This explanation is the correct one. Soda is a carbonated beverage, which means it contains a lot of dissolved gas. That gas wants to come out of solution and form bubbles, but it needs a surface to form on. This is why you see bubbles along the side of a cup when you pour soda into a glass. Although Mentos candies appear smooth, their microscopic surface is incredibly rough, providing excellent nucleation sites for forming bubbles.
Well, it looks like a chemical reaction has occurred, but in fact it was a physical. So, to quickly review, here are some questions you can ask yourself. If you answer yes to any of the questions here under physical, then it's a physical change. Is the material the same? Is there a change of state? And is it able to be reversed? In our example, the materials were exactly the same as what we started with. Carbon dioxide and water and sugar formed our cola. And at the end, the carbon dioxide, water, and sugar were unchanged. A chemical change would result in a new compound being formed. There would be a reaction, and you couldn't undo it. In this case, although it looks like a reaction, no new compounds are being formed. Alright, don't forget some of the things that are coming up, folks. We have our Properties of Matter quiz. There's a folder in Schoology for you to look at. Plenty of review materials in there, and then when you're ready, you actually click on the quiz. You have until the 18th, and there's a few tries in there in case something glitches with your computer. Please try to do your best because the final one you take is the final grade you'll get. Also, superheroes are due the class before Thanksgiving. If you're remote, that'll be the 11/25. Please submit in Schoology if you are a remote learner. You can take a picture and then revise your paragraph right in the document in Schoology. Just attach it to that assignment. Good luck and be creative and have fun with your project. Today we're going to look at the 4 states of matter, and our big question is, what are the properties of the 4 states of matter? So go ahead and get your packet out and then open it up to the page about halfway through. See if you can name the 4 states of matter. Most people get solid, liquid, and gas, no problem. But what's that 4th state of matter called? Go ahead and copy down the notes. Pause if you need to. States of matter are physical properties. These are properties that describe the spacing and speed of the particles or molecules. As matter changes from one state of matter to another, it's still the same material. All that's different is the spacing and speed of the molecules. Sometimes we call these phases of matter. Let's start with solid. Solids have a definite volume and a definite shape. This means that solids stay the same volume and the same shape. The molecules are tightly packed together. There isn't much space. In fact, they can't move at all. This means they have a very high density. Density refers to the number of molecules in a given space. Their energy is considered to be low compared to the other states of matter. The molecules themselves are not moving very much at all. Liquids have a definite volume that does not change. However, their shape can change. Liquids take the shape of their container. Their molecules are more loosely packed and are able to flow. This means they have medium density and usually medium energy. Gases have no definite volume and no definite shape. The molecules are so active and spread out that they'll fill any container that you have. Their density is quite low. The number of molecules of a gas are very low, and they're very spread out. They have high energy, which means they move quite a bit. The fourth state of matter is plasma. Plasmas are gases with added energy, such as heat or electricity. The molecules in a gas are heated, causing electrons to move around. When electrons move, they can create light. This glowing plasma ball is a great example. Lightning, fluorescent lights, and plasma TVs all rely on plasma to create a glow. A quick review. Solids have molecules that are spaced close together. They're tightly packed and have low energy. Liquids are able to change their shape. However, the volume of a liquid stays the same. Gas molecules are farther apart. They have higher energy, and they do not have a definite volume or a definite shape. That means the volume of a gas can be changed. Pressurized air is just gas that has been compressed into a smaller area. As soon as it's released, it will fill up the whole room that you give it. Plasma is a gas with all the same properties as a gas, but now it's glowing. It's added heat or electricity to gain energy. Solids, liquids, and gas, and plasma are all the same material. They're just in different states or phases of matter. The molecules themselves are the same. They're just in different locations, moving at different speeds, and have slightly different properties. Those are all physical properties of matter. Here's a solid. Pretend it's an ice cube. It takes up a definite shape and volume. However, if we heat up the liquid, the molecules will gain energy and they'll break apart from each other and form a liquid. Liquids will take the shape of the container. If we heat it more, those molecules will have so much energy they'll actually go into the air and form a gas. They're quite spread out. They'll fill up any shape and change to any volume.
Hey everybody, we'll be starting the movie in a second. Moby's just fixing the camera. Hey, be careful not to beep so close to the camera, Moby. It's pretty expensive. Hey, I think you got it. Try zooming out. Whoa, way too far. Zoom back in. Yeah, good job, I guess. Dear Tim and Moby, what makes a gas or a liquid? From Reddit. Well, gases and liquids are two of the three main states of matter. Right, solid matter is the third main state. Matter is anything that takes up space. It's the material that all the stuff in the universe is made of. All physical matter is composed of tiny particles called atoms. And these atoms behave differently depending on the temperature and pressure of their environment. Hey Moby, can you zoom in on this glass of water? As you can see, water is made up of tiny particles called molecules. Each water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. At room temperature and at normal atmospheric pressure, these molecules form a liquid. The particles within a liquid are packed pretty close together, but they're not arranged in any kind of rigid structure. In fact, they move around and slide past one another pretty regularly. Liquids have a fixed volume, but they don't have a fixed shape. If you put liquid in a glass, it'll take the shape of a glass. And if you put it in a water pistol, well, it'll be shaped like the inside of a water pistol. Hey. Alright, let's say we raise the temperature of the water. If we boil it, it'll change state and become a gas. Zoom in on that steam, Moby. When you increase the temperature of water, you're adding energy to it. The particles get excited. And when that happens, they start moving around a lot faster and get farther and farther away from one another. But the changes in state are only physical. The chemical structure stays the same. Those particles are still regular old water molecules, hydrogen and oxygen. Unlike liquids, gases don't have a fixed volume. They have a tendency to expand, which means they'll fill up any container that you put them in. Yeah, thanks a lot, Moby. Anyway, one more to go. Solids. You're probably already familiar with solid water. We call it ice. Zoom on in here, Moby. When you lower the temperature of water, you're removing energy. As a result, the particles don't move around so much. They're still made of hydrogen and oxygen, but now they're locked into a pretty rigid structure. Solids have a definite shape and a definite volume. Under normal conditions, they look pretty much the same, no matter what container you put them in. Anyway, those are the main states of matter, and they aren't just for water. All matter, from hydrogen to plutonium, can be a solid, liquid, or gas. There are actually a couple of other states of matter too, but they're not as well known. First, there's plasma, an electrically charged gas. Every star in the sky, including the sun, is made up of plasma. So is lightning, for that matter. And the fluorescent light bulbs in your classroom are actually filled with plasma too.
Okay guys, go ahead and, in your packet, draw or write down some examples of each of the 4 states of matter. And don't forget guys, the superhero project is coming up due soon. Please work on that. Make sure you have all the properties clearly defined. A picture, labeled, showing the properties in action now. Not just standing there, but in action. And effort, definitely be creative. Make sure your drawing is well done and you revise your writing so that you can get the possible highest score of 40 out of 40 points for your superhero project. Make sure you keep working on that. I'll give you some examples, and I will see you soon, or if not soon, next time when you try science. See you then.